Tiger Data is a highly comprehensive Postgres database for developers, devices, and agents. If you look at their architecture, you'll see how comprehensive it is. But this doesn't tell the story. If you actually look at their blog posts and then follow them, you will see their cracked engineering team constantly coming out with newer and newer features, and they're just packing it in, making it one of the best databases for companies like Cloudflare, Polymarket, Hugging Face, and all these top companies. But it's not very apparent all the advanced technologies that have been built into this platform. So I thought, why don't we use AI to make this architecture a bit more visual and bit more animated and go a bit more deeper into each one of these sections and show you how each one of these pieces are individually very advanced and kind of explain why Tiger Data is so advanced and what it brings to the table when you are building your apps. And if you're a marketer, at the end of the video, I'll show you how I created this video. So you can also take your architectures and architectures and then create an AI video so that you can help your prospects. All right, let's get started. So on the left-hand side, you can see that you can access Tiger Data through MCP, through APIs, or the CLI, right? And on the right-hand side, you will see that you can connect your infrastructure using Tiger Connect or Tiger Lake. But today, I'm going to focus heavily on the core platform because that's really where the majority of the action is. So let's look into each one of these pieces inside the platform. So let's dig in. Let's start with the fluid storage. Fluid storage plays a pivotal role, and it's the layer that makes Tiger Data an agentic Postgres. Now with agents, you want to be able to quickly spin up databases and then spin them down for different experiments and testing and so on, right? But if you were to use something like RDS or something on Amazon, where they may be using elastic block storage, so then you cannot rapidly spin up and spin down these databases. And also they are very expensive. So that's where fluid storage comes in. Let me show you how it works. Initially, imagine you are using a Tiger Data instance. Behind the scenes, it is storing all the data in a shared block store. And now imagine you have one or two agents that want to fork this database. So what happens is that fluid storage instantly creates what appears to be an independent database for each one of these agents. But it is actually using something called as a zero copy fork, which means all these database instances are actually pointing to the same shared block storage behind the scenes. So that's why it will be instantaneous. But now what happens is if the agent starts to write or this primary database also starts to write, then fluid storage again uses another technique called copy and write, where it copies these changed data and then creates a delta of those changed data for each one of these instances separately. So these agents, when they are seeing the data, they'll see a merged data between this changed data and the shared data from the primary database, right? So it's really cool. But what it also means is that it's very cheap because you're only paying for the data that you're using and also also only for the changed data. And because of this architecture, you can quickly spin them down as well. So that's really, really amazing. So that's fluid storage. Okay, now let's look at some of the innovations in the Postgres layer. So in the Postgres layer, there are multiple innovations and they keep adding them. But one of the things that I wanted to highlight is their hypercore engine, which allows you to store data in a hybrid row and then columnar way. What it really means to you is you can query up to 350 times faster. You can also ingest data really quickly and also 90% less storage. Speaking of storage, they also provide automatic tiered storage where your hot and most frequently used data is used in the SSD, whereas your less frequently used data is automatically moved to an S3 bucket, so you don't have to pay for all the storage. Again, it is built for speed, performance, and cost. And lastly, on the agentic side of things, as we mentioned, they already provide fluid storage and they have MCP and also provide master prompts that helps developers avoid all the pitfalls when they are building schemas or migrating schemas and so on. I hope you like the innovations here. That's the Postgres layer. Now let's look into the TimescaleDB layer. Tiger Data actually started out as a TimescaleDB, but they started adding so many more features and capabilities that TimescaleDB just didn't make much sense. Although TimescaleDB is one of the key offerings of Tiger Data. And one of the key features of TimescaleDB is called hypertables. What hypertables does is they take your time series data and automatically partition them based on time. And that, along with a bunch of other key innovations, helps you scale to billions and billions of rows. That's why a lot of these companies like Polymarket and others use Tiger Data. And second big feature is the compression of these time series data. And just like we talked about in the Postgres side of things, TimescaleDB and time series data can also be automatically compressed so that you can save a lot on storage cost without compromising on performance. And the last piece is continuous aggregation. Again, TimescaleDB automatically pre-computes a lot of key aspects of your time series data and creates real-time materialized views so that you can provide these aggregations in real time to your customers. That's really, really cool, and that's the timescale data. Now that we are done with the timescale layer, let's talk about the AI search layer. Now, let's talk about the AI search and vector capabilities. One of the innovations of Tiger Data is that it can also act as a vector database. So you don't need any specialized databases just to store your vector embeddings. You can simply use Tiger Data, which comes with something called PG Vector and also PG Vector Scale modules. And those will allow you to directly store your OpenAI or any other embeddings and directly in Tiger Data. The good news is that it performs actually better than some of the leading specialized vector databases. And the other part of this AI search capability is that it also supports semantic search. So again, you don't need a special database. You can just use Tiger Data to implement semantic search directly on Tiger Data. And that is the AI search and vector capabilities. Now that we looked into all of these different layers, let's zoom out. So now that we are done with all these different layers, I hope that you understand how comprehensive Tiger Data is. And I really encourage you to try it out and then let me know what you think. Now, if you're a marketer, the way I created this is using VO3, which is Google's video generation modules. Those are the ones that generated all sorts of animations. And then I used Google's Nano Banana Pro to actually create these images. So for this video, I ended up creating about 3 minutes of actual videos and then about 10 images. And I would say in terms of cost, I created about 10 videos and I had to redo almost all of them at least once. So basically 20 videos, and each video is about, I would say, $4 or $5. So it overall cost me about $100 to $200 total. So generally speaking, this is an emerging field, and I think as a marketer, we all need to embrace AI and start using them. And in fact, these things actually help a lot, just to visualize and explain things in a different way. It's really amazing. Anyway, I hope you liked it, and let me know what you think. Thank you.